So yesterday we learned how to create solutions to systems of equations with the matrix and using the RREF, the echelon, the reverse row echelon. Today we're going to create equations for which to put into the calculator. So here we have a question. It says Nolan is going to the carnival that has games and rides. Each game is $250. Each ride is $350. Nolan spends $52.50 altogether on 17 games and rides. Write a system of equation that can be used to determine the number of games Nolan played and the number of rides Nolan went on. Define the variables and then write the system of equation. Now, as far as writing the variables go, that's completely up to you. Always read these things, and a lot of times the numbers will kind of clue you in on what we're looking for. What I mean by that, usually the numbers, let's just underline all the numbers. There's all the numbers in our equation. You don't always use all of these, but most of the time we do. On these, we'll usually point out the equation, but it will definitely point out the variables. For instance, it says for each game is $250, and for each ride is $350. So there are two variables. Let's call it G and R. And you have to be descriptive as well. You can't just say games because you don't know if you're talking about the cost or the amount of games. So we're going to say G stands for number of games, because we already know the price per game. And then R stands for the number of rides. So that's the first thing we do, is we define our variables. A lot of time the last sentence will tell you what they are, because it will say find the number of games, find the number of rides. This one we're just creating an equation in which to put into the matrix. All right, so now let's talk about our two equations. One equation deals with dollar amounts. Usually the dollars will correlate with other dollar signs within the equation, and that's the case here. So let's go ahead and write our equations. The first equation is the amount. Usually you're going to see a how much and how many. How many rides and how much did it cost? So let's do the money. What we have is $250 per each game. Well, we know the games are G, and then the rides, which are $350 a piece, are R. So however many games times $250 plus how many rides times $350 all came out to $52.50. This is our first equation. This is the how much. How much did he spend? Now the next equation is the how many. How many rides and games? Well, altogether we know he did 17. And the way we find these 17 is we take the number of games he played plus the number of rides he rode, and this should total 17. That is usually the easier of the two equations, but a lot of times people forget that one. They want to find some kind of complex equation, but that's all it is. We find an equation that tells us how much will it cost, and then how many rides. Now, it's not always this, but it's often this. On this particular question, we're not asked to solve, we're asked to just create. But now that we have this, we're not going to do this, but we could create a 2x3 matrix, which involves our numbers, 1, 1, and 17, and then find which amounts equal this. So in this one, we will be creating and solving. So it says Stephanie and Sean each improved their yards by planting grass sod and ivy. They bought their supplies from the same store. Stephanie spent $120 on 4 meters squared of sod. Now, the meters squared is not a calculation. It's just telling what it is. So we have 120, 4 meters squared, grass sod, and 14 pots of ivy. Sean spent $105, on 3 meters of sod and 13 pots of ivy. Here's what I was talking about on the last one. When you're trying to name your variables, the last sentence will usually give it away. It says, what is the cost, here it comes, of 1 meter of grass sod, and the cost of, here it comes, 1 pot of ivy. So we're going to go ahead and name these. Let's go ahead and call it grass and ivy. I don't like using I, but we're using it. So this is the amount, the cost for the grass, and this is the cost for the ivy. All right, so on this one, we are comparing two things. We are comparing Shauna to Stephanie. So we need to create a Shauna equation, and then we got to follow that with a Stephanie equation. So let's just talk about Shauna. Stephanie is actually first. We'll talk about Stephanie. Stephanie spent $120. So her total amount is $120 on 4 meters squared of grass sod. Well, grass sod, the amount is our G, so she would be 4G because she bought 4 of those. And she bought 14 of the pots of ivy, which is our I amount here. So that would be Stephanie's amount. Now we need to find Shauna's. So Shauna bought 3 square meters of grass sod, and she bought 13 pots of ivy for a total of $105. So I'm going to minimize this just a little bit. We have our variables. We have them stacked where they're supposed to be. So we're going to take them to a matrix. The variables are generic, so we don't need our G's and I's in here anyway. And 105. So we will create a matrix in our calculator, and we are going to reverse row echelon this amount. And I'm going to name this A whenever I go to my calculator, and I will bring that answer right back to you, and we'll have our solutions. So we see our identity matrix saying that our information is good, and this tells us whatever the first variable I chose was, the result is 9. Well, the first variable we chose was the cost for the sod, so this would be $9. And then it tells us the second column, second variable, whatever that is equal to 6. Well, this is the ivy cost. I should have labeled that. So the pot of ivy cost is $6 per pot. So this is how we use our matrix to solve these word problems. Today we learned how to create them as well. You've got a Delta Math assignment. You can begin on that.